Rectangular features of size, parallel surfaces, such as slots, rails, and tabs. The datum feature symbol on a key seat aligned with the size dimension, showing the width is an example, and attached applicable to the feature control frame, C in the example on the left, or it can be attached to the size dimension as shown in B, and attached to the dimension line is another option. Incorrect to show the symbol on a center line. So avoid putting it on an actual center line of the feature. Okay, simulation of a datum of a feature of size. The datum axis created by cylindrical datum features of size are referenced at regardless of material boundary, or RMB, is the axis of the actual mating envelope, or AME. AME is not constrained when datum feature of size is the primary datum. Unrelated actual mating envelope when unconstrained. AME is constrained to the higher precedence datum features if a secondary or tertiary datum exists. The related actual mating envelope is when constrained, so that would be a bolted down state unless you have the symbol that allows it to be constrained in a free state. Datum feature references in a feature control frame. Okay, so we identify a datum feature has no impact on fabrication requirements unless the reference is made to the datum. The datum feature reference appears in the feature control frames or notes. The number of references depends on the type of tolerance specified and the level of control. And the number selection based on the degrees of freedom that are needed to constrain the design. In summary, in this unit, you learned the difference between theoretical datums and physical datum features, as well as how datums are established in manufacturing and inspection processes. You also explored how to create a datum reference frame using feature control frames and properly identify datum features with target points, lines, and areas. Additionally, you practiced making accurate datum feature references while following the correct order of precedence. Mastering these concepts will help you ensure that parts are consistently produced and measured according to your design intent. In conclusion, you were able to define the difference between a theoretical datum and a datum feature, explain how a simulated datum is established, explain how to create a datum reference frame through references made in a feature control frame, and utilize all methods for identifying datums, features, including the use of target points, lines, and areas. And you were able to make a datum feature references in a feature control frame using the correct order of precedence. Again, this covers up to page 216 or 17 in the textbook. The next series for Unit 7 will continue. The textbook doesn't have the best even break for some of these topics. So in the following pages after what I've assigned, they do talk a little bit more about precedence, but we will pick up on the topic that follows that. Thank you for listening, and if you're trying to find the dividing line in the book, reference the last image, which was figure 6/36, and the images that are beyond that are not included in this presentation. Thanks a lot, and I'll talk to you on the next one.